Hi guys, and welcome to Minecraft. This is Flandyn, and this episode is going to be very exciting. And today I'm going to show you how to build an CPU and an ALU. ALU first and CPU afterwards. As you saw in the last episode, we built our adder and the RAM. So in this episode I'm going to start with the adder to show you how to upgrade it into an ALU. So the first thing I want to start with is how to close the AND gate. When we close the AND gate, aka the carry in, we will remove the AND gates from the half adder. When there is only an XOR gate left, or two, this will have an XOR functions. It's very clever actually. So there we go. Okay, now we can turn on and off the carry in. So in default it is an XOR gate. Right now it is an adder, and right now it's an XOR gate. It's pretty simple, huh? So the next thing we need to have is either an NAND gate, AND gate, NOR gate, or OR gate. So we need to find that somewhere. Well, I know from on this design you can easily add it by doing this. There's also some methods to do it without the adder, but this is a very good adder for the ALU job. And right now I'm going to show you how to make an very good XOR gate design for the NOT functions. So right now I am starting on the NOT A function, and it's very good to know a lot of XOR gate design. When you have a lot of XOR gate design, you can always perfect your components. Though if you have a lot of designs, you will probably get a bit confused after time. So I have like 7 XOR gate design I'm often using. So this one is the 3 tall one. I'm using short one because I'm going to use 2 on top of each other, which will take some space. So right now I made my first XOR gate design, and now I'm going to start on the second one. So moving here, I want to get them as close as possible. So moving on, placing everything so it works. Yeah, and I'm just going to use regular inputs for now. The inputs are right now here, and I will change them a bit when I come so far. And one thing you may can see is that my XOR gate design is almost as similar the entire way through. I'm going to change this a bit. I'm going to remove this block here, and change the XOR gates just barely. As you can see, it was a torch right here. I changed it down here. So this torch will still power this block and this redstone and this redstone and block. But before, the torch went up in this block and will power this redstone, and it will still go here. So it's just the same, just slightly different. And so now we have our NOT gates. I'm going to make an so it automatically NOT all of the bits instead of doing everything manually. So to do that, you could add and repeater here and redstone here. So the second thing you need to do is to get the user input here, and now we could partly start. I'm just going to take a slight look how to do this. There's different ways to do things, so yeah, right now I think the easiest way is to do like this and have the next user input here. And when I'm thinking of it, I'm going to place the lever here and here, so they won't interfere with each other. And then I could do like this. And right now I made a stackable NOT gate design. It's very short for being NOT gates. That's the highest point of the ALU. And right now we need one more NOT gate, and this one is going to be NOT R for NOT result. And then I can just use the same design because it's actually a very good design. It's very, very good. Allowing these extra gates, it's very small, compact. Yeah, they are just magnificent. It's nothing else. Okay, so soon done with this extra gate design. And tutorial on extra gate design is also something that we should have more of, because extra gate design is the most important gate in this logic in Redstone Minecraft computer Redstone. Okay, so I'm doing my redstone right here and here, and now we have 3 NOT gates. So I'm going to add 2 more functions too. Right now we have NOT A, NOT B, NAND, XOR as default, adder, carry in, and NOT R. So with those logic gates we can get all the logic gates, including adder and subtraction, like all 16. So I'm just going to add shift registering, and there's a couple of ways to do that. I have one method that I really prefer. So the method is basically to turn off the signal and then go to the right. So this is pretty long one. It's like very huge, very big. So I'm dragging the signal a bit further down, placing a torch. I think that maybe I should remove this one. There's a torch here. Placing my repeater right here, and then I need to try to get like the signal. So I'm doing like this. I think that this is one of the best methods. And kind of now I want to power this redstone in anyways. I'm thinking of doing like this. So if I'm removing this, placing redstone there, here, and it will be right there. So here we have our shift registering for the right side. Now we need the left side one, including I need a way to close or to give. So Stym is pretty awesome. Okay, that's something I can agree. Yes, and yeah, I could probably add one piston so it goes like this, and then I need some kind of so I let this stay open all the time. There's also a couple ways to do this, so I'm using just an very simple method. This is also a pretty fast method, so everything will be bigger as you're adding functions. I'm just adding all the functions I really need. I probably need to remove or move that one a bit more. So as you can see, this is on the same level, so I'm just giving this one more output. Placing the torch right here. This one shouldn't be on. I'm placing a lever there to turn it off. Yeah, just don't mind. I'm going to place the torch on this side now. I'm doing it on this side because I'm going to stack later and show that it's stackable. I am very sure that this is stackable, by the way. So I could probably change this like way better if I'm doing this. Oh, that wasn't the cleverest thing I did. What's up here? Like, oh yeah, sorry, I removed something. I'm very sorry for that. That's so noobish. So I'm just keep going here, and I'm going to change. Okay, I'm not going to change anything when I'm thinking of it. I'm just going to change one bit slightly. So right here I could place my repeater and my redstone. And here is the final output. I'm dragging that 2 more. And then I need just the piston left. And here it is. Here is an perfect ALU. I would say perfect like this. People can disagree with me, but this has all the necessary functions. You could probably make a better one, of course, but this one is such a good ALU. It's one of this is my favorite ALU designs. I know about something that could make a better ALU, but this is just so perfect. It's so, yeah, it's just magnificent in every way. So right now I'm going to do stack 3 to show that it's stackable. Oh, stack 3. And as you can see, it's stacked now, and bear with me and hope it works. I haven't actually tested it. So I'm dragging the outputs to make the functions. These levers are the functions side. I like to keep all the functions on one side, except the carry out or the close carry out needs to be right here. So I'm going to add that function. Basically now I have an add remove carry out function, which is necessary, I would say. 2, 3, 4, 5, 6, 7, 8, 9, 10. And there we have it. Now if I would just leave it like this, it would be crazy, because I don't have any. I need really to have kind of a system on how things works. So I need to write the signs. Just looking for where is the. Here it is. I never did the repeater thingy here, so I'm just going to add that. And in a matter of seconds now, it will be working 4-bit ALU, which is just awesome. And this is the last redstone placing, and here it should be. Let me see, and let's count my functions. Just going to add this redstone. So not B, not A, NAND, adder, carry, add to carry in, not R, remove carry out, shift register right, and shift register left. So that's all the functions we really need. Let me remove this wall. Okay, so this is probably one of the best best ALUs I've seen better. So don't say that this is the best, but it's one of the best. It's one of the best ways to do this. So now I'm going to take this RAM. The RAM is very important in this. So I'm going to place it on a very good spot. Copy, or I could do cut, and paste it. Let's see, somewhere right. Paste, and this is good enough. You may wonder why I have so much space in between, but it will come in advantage. By the way, this is not the best RAM design you can have. If you want a really good one, you need to have a dual read RAM, but I'm not that advanced at the moment, and you don't necessarily need one, but yeah, it's very helpful. So let me do here stack 3 I mean, sorry, and here is 4-bit RAM, but I like to do the have it bytes on the RAM. So this is not quite bytes, but it's 4 times 4-bit RAM, which is good. Stack 3. Here everything is, the piston isn't glitched. Perfect, just beautiful to look at this. Do the buzzing between. And as I said now, I finished the ALU and now I'm working CPU. For the CPU you need RAM, ALU, and user inputs. So the one memorized is that you need to, the RAM and ALU need to work so much together, and with the shift I could do multiplying and subtraction, no, multiplying and dividing. So I need to bring this output somewhere on the I need to bring this output back into the ALU on the one side. I can probably just bring it the entire way. Let me count. 1, 2, 3. Okay, so I could have output on both sides. Let me just place repeaters here. So I have some outputs. I also need to make the inputs here. I haven't done that quite yet. I'll probably make this in 2 parts. I'm not sure yet. Okay, so now we need to wire this back up to the I know it's going to be some cross wiring, because I'm going to have the user inputs going into this. At the same time I'm going to have the adders to do some things. Basically I want the ALU to work together with the user inputs and the RAM work together with user inputs, and in all the ways. So now I'm making the inputs between, and this is also buzzing, which in this right now it's pretty necessary for everything to get the best inputs. Okay, so I'm just going to cut it right now and make it the buzzing down. Welcome back. I just finished my buzzing and I placed the levers and did the functions better. So right now I'm going to show you how to do subtraction. To do subtraction we need to do something called 2 complements. By doing using the adder with add carry in and remove carry out. In addition to that we need to not be. And I had some problems with this because of the server lag, so let's hope it works. I think it might be some wrong with this not this torch, but maybe this one up here. It's fine. And you just need to look for the wrong. Okay, here it is. So there is some wrong things with this. It looks good now. For some reason these two are still on, which is kind of strange. Oh yeah, this one needs to have. Okay. So sorry for that. Like, this needs to have. Yeah. Now it works. It should work at least. So this one has some problems, it seems. It's because this one won't activate. So there is some torch activates problem, not with this server. Sorry for that. But right now it will do subtraction. Because of the add carry out, it won't work. So let's do some subtraction. So this is, let me see, okay, this is A1, A2, A4 and A8. This is B1, B2, B4 and B8. So let's do A8 minus B4. This is the B4. And let's hope it says 4 now. So 1, 2 is off, 4 is on, and 8 is off. Works perfectly. Let me try to add A1 minus B2. And now there is still some torch activating problems. I'm so sorry for that. Or it's just slow or something. So look here, like this is an activation problem for the torch, which is kind of bad. I don't think that should do anything, but still there is a lot of stuff that should be more fixed. So I'm just trying to fix the torch that has the problem right now. Now one of these, like all of these are wrong. No, sorry, this one is wrong. So it's A9 minus B6. That should be 3, so there's something wrong with this one. This wasn't as fun as I hoped, because I hoped this one would go much smoother. I found the problem, and now it shows 3. So this is subtraction. It's very fun method to do it, because in binary they don't have negative numbers. So this is why we're doing it like this. Thank you for watching. This is an CPU, one of the best ALUs. And thank you for watching. Please subscribe, comment and like for more videos like this.